Good morning. This is Ruth Shepherdson, and this lecture is on shielded metal arc welding, which is also referred to as SMAW, arc welding, and stick welding. This is a very common process in the welding industry, and it's one of the most versatile. In a small shop situation like ours, there's usually electricity available. Our welders happen to plug into 220 outlets, but they do make welders that also plug into 110. Outside of a structured building area, there it's pretty common for arc welders to be either hooked to generators or to also be a generator. So it's more of a scenario where a fuel source, like gas or diesel, is poured in, and that generator generates electricity to then perform the weld. This makes it very versatile in rural places without electricity. Some of the other benefits of arc welding or SMAW welding include being able to weld in the wind because we are burning flux to create a shielding gas. That makes it more versatile than MIG welding. It also has very large amperage ranges, so you can weld from a smaller amperage to a higher amperage. This makes it great for industrial and pipeline welding. When you're getting ready to arc weld, there's about 5 different things we want to do that will help make you more successful. The fifth one is actually striking an arc. So that's when the process actually starts. But half or more of your success as an arc welder really does depend on preparation. So in your notes packet, there's a place for you to take down some notes on each of these processes. You did some of this yesterday, but I just want to describe a few things to you. The first thing you'll need to choose is the metal. We are going to be arc welding on mild steel. If you have the right electrodes, you can actually weld on stainless and other alloys, but because of our ventilation system, we'll stick with mild steel. The metal should be clean of rust and paint. And so if you end up picking up a coupon, say that's real rusty, you'll want to go ahead and clean that. And you'll definitely want to pay attention to the thickness. This can be done with the little metal gauge reader that's by the CNC plasma torch, or you can use a tape measure and do that. So you can see that based off the metal thickness, that's how you choose your electrode size, and that's what gives you your amperage range and helps you set the welder. The first weld you're going to be doing is on 3/8 inch metal. You could use up to a 5/32 electrode size, and we're actually going to be using a 1/8 electrode size, so your welding amperage will be between about 90 and 140. You might go a little bit lower on when you weld 60/10 as opposed to 70/18, but we're going to be right in there. The next thing you'll do is choose your polarity. The welding circuit that is created when you turn on the welder has a negative and a positive pole, and they call this polarity. Polarity matters when you are welding because choosing the right polarity affects the strength and the quality of the weld. You can weld in either AC polarity or DC polarity. If you weld AC, you actually switch directions 60 times per second. Alternating current is a little bit more level, but it usually is not quite as powerful. Most people in industry prefer to weld with DC. Now you can see from the two diagrams between DCEP, which is electrode positive, and DCEN, that the only big difference is which way the electrons travel. Depending on the way those electrons travel, the heat concentrates in a different area. And so, weirdly enough, the heat concentrates where the negative is. So in DCEP, we see the workpiece being where the negative is, I think you can see that in the diagram, which means that that's going to provide greater penetration. In DCEN, we see that the negative being is where the electrode is, and so we see more heat being produced there. Before I leave that slide, the three process welders you'll be using in our shop actually leave, if I remember correctly, they're auto set to DCEP. So when we use the auto set features, that's all you're welding on. We do have an older welder where you can swap that out, and I would encourage you to try that. Now, as part of choosing your polarity, you also then will connect that with your electrode, or you will choose your polarity based off the electrode you have, which is actually more common. The electrode you'll start with this morning or this unit is going to be 6010, as you can see in the example on the screen. The E in that stands for electrode. The 60 stands for the minimum tensile strength, and we'll study tensile strength a little bit later, but that's a measure of strength in welds. The 1 tells you what position you can weld it in, and then the 0 tells you what type of current or polarity you can use. So as you look at 6010, the last digit is a 0, which means that the coating on the electrode is high cellulose sodium and that you can weld it on DC positive. Now, you'll also weld with 7018 in this unit, and you can note at the bottom that that stands for low hydrogen potassium and has iron powder in the coating, and that because of that, you can weld it in either AC or DC plus or DC minus. So it's a very versatile electrode. That brings us to choosing your electrodes. You definitely want to match your base metal. You want to match your polarity. You want to take note of what tensile strength you want it to be. And then you're going to choose the diameter of your electrode. And we kind of have alluded to any of those and all of those. Do note that when you look at electrodes, just like that picture on the screen, always the electrode type is stamped on it. And so you should never just try one because you not knowing what it's matched to is probably not going to be very functional. Electrodes are pretty expensive, especially when you buy them in bulk. And so many people just keep around on a farm or ranch maybe 1 or 2 types of electrodes, not very many. And so we see in agriculture a lot of use of those versatile electrodes like 7018, and then 7014 is another really common one. People are oftentimes looking for something that is easy to use, burns really hot so they get good penetration and can repair things, and can be used on a lot of different structures. Once you've chosen your metal and your polarity and your electrode, it's time for you to dial in the amperage. So you need to know what type of electrode you have and the thickness of the metal and the diameter of your electrode in order to set a welder. And older welders, you actually would look at a chart like this. And so let's say I'm having you use 6011. I've given you a 1/8 inch electrode, and I want to know what amperage range you should start at. You would look at the electrode column. Once you found 6011, then you would go over to 1/8, and then you'd go to the far right where it has your amperage range. We aren't going to worry too much about the diameter of the electrode in millimeters because in the US we primarily use inches. Now, the newer welders we have in the shop have what we call an auto set. And so I will show you how to use the auto set, but essentially you tell the machine what electrodes you have and what metal thickness you have, and it actually sets all of this for you. It's like the chart exists in the brain of the welder. I was very hesitant to want to use that at first. I felt like it was going to dumb down my students because they didn't know how to look this up. And I felt like the welder would be wrong sometimes. I soon learned that even when I had it on manual, which I'll also teach you how to do, that when I would dial the welder in and think it was just perfect, that was actually what the auto set would have started it as. So I've actually been pretty impressed with the accuracy of auto start on these machines, and I think you'll enjoy getting to use them. After you've adjusted all of those things um, on a welder, you are going to then go ahead and strike an arc. And I will put this PowerPoint. I actually think I already have it up on Google Classroom, but I really do want you to watch this little YouTube video on how to strike an arc and what the different systems are. They're usually people either tap or drag. There's pros and cons to both. Definitely, beginner welders typically find dragging an easier way to strike an arc, but it definitely does leave more trash and slag, if you will, on your work surface, and so that is a downfall to that. Other people um, start by dragging an arc, but once they get used to it, they can tap to strike an arc and go forward then. So that will be one of your first scores in the arc welding unit, is to take care of how to do that. I also want to flip back to this and bring your attention to this part here where it says there are three things you adjust as you work. And I think this won't surprise you because of your experience in oxyacetylene, but as you arc weld, you can change the amperage before you start. You don't ever change the amperage while the machine's under load. But you can always change your travel speed and how close you are to your work, which is your arc length. One of the things you have to understand about arc welding is that without a bit of space for an electric arc to jump across, you don't start welding. That's how the heat is produced. And so by having a longer or shorter arc length, you can actually change how your weld works. The other thing I would leave this slide up for is that I find this particular chart to be a very beneficial one to just have for reference, because it has some very common diameters of electrodes. So if you want to take a picture of this to leave it on your phone, I have it hanging over in the welding shop. But particularly those of you that go on to compete in ag mechanics, you don't get to have those sorts of aids with you when you walk in. So I generally tell people, if we're starting welding with 6010, I advise that you start at right at about 100 amps, and if that's for 7018, probably 120 is a good place to start. And then, as always in arc welding, you adjust up or down based off the things you're seeing in your weld. This gets us a little closer to being ready to arc weld later this week. Do make sure that by the time I am back on Thursday, that you have turned in your vocabulary, that you have practiced for an equipment test, and Wednesday you will actually take the test in class, and that you have turned in these notes for a score. Have a great day.